Hi everyone, my name is Gagana. Today I will be presenting technical seminar on water quality monitoring to conserve water resources using IoT. So, what is water quality monitoring? Water quality monitoring is an sampling or analyzing the water in river, lake, pond and streams too, and evaluating the physical, chemical, biological characteristics of water. And conservation of water resource means using less water and recycling the used water so the water can be used again. Let's move on to the content part. Contents as abstract, introduction, literature survey, problem statement, proposed system design, application and future scope, conclusion and reference. Let's move on to the abstract part. Internet of Things, that is IoT, plays a very important role in agricultural industry. The soil and the water gets contaminated due to the accumulation of waste, which affects the health. The main aim is to design and develop an IoT-based system that can sense the water contamination and quality. Sensors are used to detect the hydrocarbons, chemicals, metal content in the soil and can be integrated into a soil probe for monitoring the soil contamination. Sensors are used for detecting pH, conductivity, dissolved oxygen, turbidity, etc. Can be used for monitoring the water quality in the river, ponds, etc. There are four sensors used in this process. There are turbidity sensor, conductivity sensor, pH sensor, and temperature sensor. These four sensors are used for different process. Let's move on to the introduction part. Water is the most valuable thing to keep human beings alive. In 21st century, due to the lot of invention, development, growth of manufacturing industry, the population, pollution and the global warming rate is being increased day by day. In India, much of this is generated waste ultimately is dumped in the surrounding land. This causes method of dumping waste as finally creates a mass of rubbish that can no longer be properly managed. There are no reliable statics in this country and most water supply industry lack water pipeline monitoring technology, make it even harder to predict the cost to detect and repair the losses. As they said, water is the most valuable thing for human being and animals to keep alive. Let's move on to the literature survey where I have referred three papers for this project. In paper 1, the topic is water quality monitoring and waste management using IoT. This was published by Manisha V. Ramesh in 2017. The main aim of this paper was to design and develop an IoT based system that can sense the environment parameter and effectively deliver the information on the level of contamination and the quality of sensor. The main aim of this paper was to deal with the quality of water and to know how much the water is contaminated. They have used sensors to detect that. Sensors to detect the hydrocarbons, chemical, metal content in the soil can be integrated into the soil probe for monitoring the soil contamination. In paper 2, the topic is the design and implementation of the cost-effective water quality evaluation system. This was published by MOFQ in and IHMO in 2018. In this paper, the system is a microcontroller based system with higher degree of accuracy. In this is it determines several parameters of water such as temperature, turbidity, potential of hydrogen, that is pH. It also makes possible to find the sensor values and display on LCD. One of the main part has been taken from this paper too, that is different that is displaying the value on LCD and usage of sensor. And one more paper is in paper 3. The topic is multilinear regression based water quality parameter modeling to detect hexavalent chromium in water, that is drinking water. It's published by KSD Krishnan and PTV Bhuvaneshwari in 2018. It represents the relationship between the pH and total dissolved solid, that is TDS, and conductivity water system choice parameter, that WQPS. And those constant quality will be involved in spotting the hexavalent chromium material solvent in drinking water. This paper deals with the drinking water, whether it contains in chromium, hexavalent chromium in it. These are that is total dissolved solids, conductivity, water system parameter, and those constant quality are involved for spotting an hexavalent chromium material solvent in the drinking water system. This was the reference papers I have used, and next is problem statement. There are two problem statements where one is to monitor water quality present in remote location in rivers and canals. That is to identify the quality of the water and the water which has been left from the industry. That is manufacturing industry outlet water, and to test them. The second problem statement is to check the purity of water, to know how purified water it is, and which is being left to the water bodies directly from the industry. The industries will leave the water to the water bodies directly, and we have to know what purity of water they are leaving. This is the two problem statement and proposed system. This is what we have done in this paper or project. By utilization fundamental measure synthetic reasoning material property in H2, that is water, which can undertake problem solving. pH detector investigating pH level H2O, and the content will be displayed on LCD. The pH detector will detect the pH level of the water, and the content and the value will be displayed on LCD. Once the betterment is done, the device sound mechanically to check for the result that has been displayed. Means once the complete process is completed, the alarm there is an alarm which make a sound which or beeps that the process is completed. Now you can check the value in the LCD display. No need to check semi-automatic for the result, which take much time consumption to give the result. Wi-Fi module is used to associate with WS Cloud. There is an Wi-Fi module which is connected to the AWS Cloud. AWS Cloud is an Amazon Web Service where it is used to store the data, retrieve the data, recollect it, and reuse it again. That is the process in AWS Cloud. A Wi-Fi module is used to associate the AWS Cloud for storing and recollecting the data. They are used for storing and recollecting the data. By using Wi-Fi and Amazon Web Service, we can use it. We can use the store use we can use to store and retrieve whenever we need. Whenever we need, we can save it or retrieve the data from AWS Cloud. This is the usage of Amazon Web Service Cloud. Let's move on to the system design. There are Arduino microcontroller is connected to 4 sensors: turbidity sensor, pH sensor, temperature sensor, conductivity sensor, and it is also connected with the power supply, alarm, relay, Wi-Fi module, LCD display, and this Wi-Fi module is connected to AWS Cloud. Now let's know the process of this connected devices. Product turbidity sensor. It checks the transparency of the water. The process of turbidity sensor is used to check the transparency of water. pH sensor are used to check the alkaline in the water, and it also determines the pH level. Temperature sensor is used to determine the temperature of the water, whether it is cold or hot or normal. Conductivity sensor are used to know the chemical solvent or the chemical solution in the water. These are the different sensors that are used in this process and their functions. LCD display, it displays the value of the water. And alarm, once the LCD displays the value, alarm starts making sound or beeps that the process is ended. Now we can go through the checking process. And power supply is used to supply the power to the Arduino microcontroller. Relay is another type of power supply. Instead of power supply, we can also use relay whenever it is necessary, when power supply is not in use. Wi-Fi module is used for the connection between the AWS cloud, that is Amazon Web Service Cloud, which where we can store and retrieve the data or the information. This is the process of this system design. I mean this process of this system. Let's move on to the application and future scope. The advantage in this system is low power consumption. As we have seen, there very less power is consumed, no carbon emission, there will be no carbon emission, more flexible to deploy at the remote site. It is more flexible, we can deploy at remote site only. Using various simulation tools, the recorded data can be analyzed for future correspondence and action. Using various tools, the data which has been recorded can be used for future correspondence, and we can take actions too. The development of IoT technology provides us approaches to real-time data acquisition, transmission, and processing. The data which has been collected can be processed, transmit, and use it. Water pollution status in remote region can be achieved by monitoring the quality of water. By monitoring the quality of water, by knowing the quality of the water, we can know the status of the water pollution in particular region, and collecting comprehension data. And by knowing the water quality there, we can collect the some set of data. In upcoming work observes quality, waste product material in H2O. Physical structure that release factories examined automatically by the formulation. It determines the waste products in H2O. These are the application and future scope in this process. Let's move on to the conclusion. Sequential flow up of water pollution status in remote region can be achieved by monitoring the quality of water and collecting the comprehensive data. Means it collects the data and it also determines the quality of water. This can be achieved and followed too. This system not only provides comprehensive evaluation of water environment, but also can quickly discover urgent water pollution accident or natural disaster, transferring the abnormal water quality information. It also helps in dealing with an abnormal water quality information, and urgent water pollution accidents can be quickly brought into a normal form of water, and to monitor center by quicker communication network. And this can be done through the communication, and provides graphical reference for the decision making department to comprehend the status of water, and it also determines the status of water. Let's move on to the reference part. There are 4 references which I have tipped for this paper or the project. One is MO for Q and IHMO and MNHQ are published. They have published design and implementation of cost-effective water quality evaluation system in 2018, and KSB Krishnan and PTV Bhuvaneshwari have published multilinear regression based water quality parameter modeling to detect the hexavalent chromium in drinking water, as we have spoken earlier in literature survey. They have been published in 2018. And one more paper was Manisha V. Ramesh published water quality monitoring and water management using IoT in 2017. I would like to thank my guide Rajendra sir for supporting and guiding me, and thank you everyone for listening this.